everyone. Thank you for being here, Emiliano. So, I'm Dr. Charu from Qure and I'm with Dr. Emiliano from Mass General Hospital. Dr. Emiliano is a postdoctoral research fellow at Mass General Hospital and he does a lot of work for validating AI algorithms. He recently worked on an abstract for early diagnosis of heart failure and he's here with us today to talk more about his research.
Thank you, Dr. Saru. Yes, so it was a great project that we did. I think opportunistic screening right now in radiology, it's a big field. The possibility that AI has given us to measure and quantify things that normally it will take a lot of time to radiologists to do are more and more common. And the product that you are developing, I think the results we got were really good. What we did was to collect patients without the diagnosis of cardiac failure, and then we started to follow these patients in a retrospective way to see which of them developed cardiac failure after the chest X-ray. So in this retrospective study, what we did was to create two groups of patients. The first one was patients that had a chest X-ray, and then we checked that they didn't develop any heart failure for up to 2 years. And then we collected a second group of patients in which after the X-ray was taken, within that year after that, they developed a heart failure diagnosis. So after using your solution, which is a combination right now of your estimation of cardiomegaly or the cardiac size and the presence and quantification of the pleural effusion, your team made an index that then we use to classify these patients into high risk or low risk for heart failure. Our results were good. The AUC in on all the cases was 0.8. Then we did two sub-analyses according to the ejection fraction and also to the time between the X-ray and the diagnosis. And as we expected, obviously the time closer to the diagnosis had the higher AUC. The higher AUC that we got was 0.83. And also the patients with low ejection fraction also had a better AUC than those without it. So I think there's this solution can help make our patients aware of their conditions, because we know that heart failure at the end of it's the end of a lot of cardiac diseases, and sometimes people are not complying with their medications. They have some symptoms, but they don't know what's that about. So if X-ray as a very common modality and as the most common used modality in radiology, being able to use this tool in the background and just flagging patients that the index that you created consider that they are at high risk of heart failure, I think it's a good way to catch patients that are at high risk, making obviously other studies to confirm the diagnosis and then maybe start their treatment earlier. I think these type of solutions are very valuable. I think that the opportunistic approach of radiology with the AI, the quantification of anatomical structures that we are now able to make in seconds instead of minutes can help us, and you especially, your team can make develop better tools that can have good clinical impacts on our patients.
Thank you, thank you. I think you were explaining the study really well, and also congratulations. You got the RSNA Research Award for this, so many congratulations for that. I wanted to just get your views on the fact that does diagnosing heart failure through plain films or chest X-rays does that make it really powerful in a very specific way, because we are diagnosing heart failure, but on a modality like plain films. So what is your view on that?
Yeah, so I think that that's very important. Again, for cardiac failure patients, the timing of the diagnosis is everything, because that also means timing of treatment. So that's very good for the. It has clinical impact, and yes, as you said, to my knowledge, using this type of solutions on chest X-ray, it's not available. I mean, I've seen something related to correlating pulmonary capillary pressure, and also there's something about mortality, but for heart failure, I think that there's nothing out in the market. So I think it's very valuable to continue develop and to continue to discover and construct these solutions for patients to have a earlier diagnosis and earlier treatment.
Thank you, thank you. That's very good to hear. And yeah, definitely chest X-rays are performed so widely, and they are the cheapest investigation also available. So we are glad that we are able to add value to the diagnosis and treatment of heart failure. Thank you for your amazing work on this research, and we hope that we can collaborate more on innovative things.
Yeah, of course. I think that maybe in the future, if we could do a prospective study, that will also be really interesting, because we need to still we need to be sure that these solutions have a clinical effect on our patients. That's at the end of the day, that's what we do.
Yeah, I mean, to have AI tools that can improve clinical outcomes is the real value of AI, right?
Exactly.
Completely agree with you. Thank you so much. Thanks for your time.
Thank you.
Thank you for being here.
Thank you.